Welcome to our lesson on thermometers. What is a thermometer again? It is simply a device that is used to measure heat energy. But how does it work? Well, as you may know, when things are heated up, they expand. And when they cool off, they contract. So that same principle is what is used in our basic liquid in glass thermometers. There are basically two types of thermometers: liquid in glass thermometers and electrical thermometers. What principle do the electrical thermometers work on? Well, whenever things are heated, namely metals, then a current will run through it from one end to the other. If you measure how much current runs through it, then you can measure how much temperature there is, because the amount of current is directly proportional to the temperature. If we look more closely at liquid in glass thermometers, we will find that there are two liquids that are generally used in liquid in glass thermometers: alcohol and mercury. Each liquid has its own relative advantage and disadvantage. Mercury is better for measuring higher temperatures because it has a boiling point of 357 degrees Celsius. Meanwhile, alcohol only has a boiling point of 78 degrees Celsius. So this means that you can't use alcohol to measure the temperature of something that is boiling, such as water. On the other hand, alcohol is better to measure colder temperatures because its freezing point is negative 115 degrees Celsius. Meanwhile, the freezing point of mercury is only negative 39 degrees Celsius. So alcohol can be used to measure colder temperatures. For example, if you wanted to go to explore Antarctica, since it can measure colder temperatures as cold as Antarctica gets, it would be better to use alcohol. Next, we look at two common types of thermometers. There's the laboratory thermometer and the clinical thermometer. The laboratory thermometer is used, as the name implies, in a laboratory, and the clinical thermometer, as the name implies, is used in a clinic, such as a health clinic. So if we compare them, you should notice that the laboratory thermometer has a much greater range than the clinical thermometer. The laboratory thermometer usually goes from minus 10 degrees Celsius up to 110 degrees Celsius because it is used to measure things that are freezing cold or boiling hot. So it needs to go below 0 and above 100. On the other hand, a clinical thermometer has a very narrow range, usually of about 7 degrees. Its range is usually from 35 degrees Celsius up to 42 degrees Celsius. Why is it so narrow? Well, it doesn't need to measure much lower or much higher than that because it is used to measure the temperature of humans. And the average human body temperature is about 37 degrees Celsius. If it is lower than that, then you don't need to measure much lower because you have hypothermia. Your body will be too cold and you'll most likely die. On the other hand, it won't go much above 37 degrees Celsius. You may have a fever that will rise to 3, 4, or 5 degrees above that, but if it goes too high, then again, in that extreme case, you are also most likely going to die. That is called hyperthermia. Another difference between the two is their cross-section. The laboratory thermometer has a circular cross-section. Meanwhile, the clinical thermometer has a pear-shaped cross-section. It is shaped like a lens. And the clinical thermometer has that cross-section so that the numbers on it can be magnified. Why do you want it to be magnified? So it can be read easily. Why do you want it to be read easily? Because in the event of an emergency where someone has a fever, you need to know exactly how high that fever is in a very quick amount of time. You don't want to be wasting time as a nurse or doctor trying to read this scale. You want it to be seen clearly right away. Another design feature that the clinical thermometer has is there is a constriction near the bottom of the thermometer, which is called the bulb. That constriction is there so that when the thermometer is taken away from the person's mouth or arm, then the liquid does not go back down. It constricts it, it binds it in place. Why do you want that? You want the thermometer's reading to stay where it is so that you get an accurate reading. Imagine if the constriction was not there. Then the instant you moved it away from the person, the liquid would start falling down again, and hence you would not have a good reading. You may have noticed that the nurse, when she's finished with the thermometer, gives it a little flick. Why does she do that? It's because you need to provide an extra force pushing the liquid back down into the bulb where it is stored. This reminds me of something I have seen before. I have seen people flick a digital thermometer. There is no reason to flick an electrical thermometer. There is no liquid to push back down. So people have seen nurses do that and they don't know why, and then they just continue doing it. A couple other design features that may vary on thermometers, whether clinical or laboratory, are the capillary bore and the thickness of the bulb. What is the capillary bore? Well, that is the little circle inside of the thermometer where the liquid is stored and rises up in. If it is wider, then there is less precision because it will take more liquid to fill up that container. But if it is more narrow, then there is greater precision because it takes less liquid to rise up that capillary bore. If it is less liquid that rises up, it's going to rise up quickly, so you can get between degrees Celsius. You can get up to 0.5 degrees precision. When it comes to the thickness of the bulb, which is the walls of the glass containing the reservoir of the liquid, the thicker it is, then the slower it will react. And the thinner it is, the faster it will react. Why is that the case? Well, when you take a thermometer and you place it in contact with a heat source, the heat has to first pass through the glass bulb before it heats up the liquid of the thermometer. And so if the bulb is thicker, it will take longer to pass through the glass bulb and finally heat up the liquid in the thermometer. Hence, it will take a longer time to respond to its reading. But if the bulb is thinner, then it's going to pass through quicker and the reading will be obtained in a faster time period. The quickness of the reading is an advantage of digital thermometers over liquid in glass thermometers. They can take temperature readings much quicker than liquid in glass thermometers can. And with that, we come to the end of this lesson. See you in class.